So this is still section 3.2. Solving systems method 2 is using elimination. So you use this method when the variables line up. When the variables line up. And we'll do two examples of this. And this is actually more common to see, especially when we do applications. So for example, let's say you have 9x, we'll start with the easiest kind, 9x plus 9y equals negative 45, and 5x minus 9y equals 3. So we want to solve that system, and notice that neither x nor y is alone or solved for already, so it would be very hard to do substitution on this.
Yeah.
But the x's and the y's line up very nicely, and conveniently when you add the two equations together, the y's will go away. So actually this is 9x plus 5x is 14x. You just simply add going straight down. 9y minus 9y is nothing, so it goes away. And negative 45 plus 3 is negative 42. And we're just one step away from solving for x. By dividing both sides by 14, you get x equals negative 3. So we're halfway there. Of course we need the y coordinate. So you take what x is and you plug it back into either equation. It really doesn't matter. So I'm just going to pick plugging it in there, but it will give you the same thing either way. So plugging it in there, you get 9 times negative 3. Always use parentheses when plugging in, plus 9y equals negative 45. And you just need to solve this for y, and then you'll have your other answer. So this is negative 27 plus 9y equals negative 45. We add 27 to each side. You get 9y equals negative 18. When you add, you do plus 27 to both sides. Divide by 9, and you get y is negative 2. So your answer for this is the point negative 3, negative 2. And the answer is always an ordered pair because it's the point of intersection. This is the x coordinate, that's the y coordinate, and that's where they would cross each other. So now, unfortunately, it's not always so easy that when you add them up, one of them is eliminated. Sometimes you have to do a little more work. So second example, 3x minus 6y equals 9, and negative 4x plus 7y equals negative 16. Alright, so we're looking at this example, and we don't just get to add them together because nothing will cancel and we won't be able to solve it. But there's a trick that actually always works, and that is that you just switch. So since the 4 is the leading coefficient here, you multiply the top one by 4, and since the 3 is the leading coefficient here, you multiply the bottom one by 3. Literally just swap those, and you'll see that what happens here, because this is already the opposite sign here, when we'll rewrite each equation after we multiply it out. So you get 12x minus 24y equals 36 for the top equation. And watch what happens here. You get negative 12x plus 21y equals negative 48 when you multiply through. And now this looks like something where one of the variables will easily cancel and we can solve it just like we did before. So you get, if you add, the x's go away this time, so you get negative 3y equals negative 12, just adding straight down. Divide by negative 3, so you've solved for y. And I'm just going to say at this point that because we've done enough examples, you plug the y back into either equation, you'll get x is 11. So your other answer will be, so your full answer will be the point 11, 4, or the ordered pair 11, 4, which would be the point of intersection of those two lines if you were to graph them.